Welcome to Applied Programming, Lecture 7, Validation and Product Mindset. We will start with a short overview of what we have done in the previous lecture and what we are going to do in this lecture. And then we will walk through some of the theory. The first part of the theory would be about software development. And in particular, we will be talking about forms and validation and advanced data representation. And the second part will be about product mindset. After that, we will have the hands-on part where we will continue building our own web application. Overview. Previously on applied programming. You'll remember that last time we sort of described what we have learned so far as different building blocks, and then we put these building blocks together. In the end, we have this layered structure. At the bottom we have database. Above that there's the backend and there's web API. On the top there's the front end. Front end was connected through the web API, and that was what we did basically previous lecture. But we did something else. We also created components of our applications. So before going through that, I would like you to look at this photo. These are ingredients of open sandwiches, Danish open sandwiches. And it's important the way you order these ingredients or choose these ingredients and you prepare the sandwiches. So similar to this photo, we also created different ingredients. For example, student card, student list, teacher card, teacher list. These were the components in our Angular work, and you can have this simple analogy. They are similar to the ingredients of open sandwiches. Other than the components, we also had services, and you can think of it as the waiter. And we also had the models, which you can also think of as the menu or the recipe. This week on applied programming. Now, we would like to ensure these. So, properly formed open sandwiches. And we would like to avoid those incorrectly formed open sandwiches. So for example, the first one has ice cream at the bottom, and then there's fish on the top, and you can see that one can also create these combinations, but these are not the combinations that we would like to have. What else on this week? So we just talked about this analogy about the components, services, and models. We will add a new component that is called Edit Student. Other than this, we will also talk about the product mindset, and we'll learn a little bit more on the Angular side. First part of the theory, let's look into validations. What are validations? Validations are rules that ensure data meets specific criteria before it's processed, stored, or transmitted. Why do we validate? There are different reasons. For example, data integrity. We would like to ensure data is accurate and meaningful. Another factor is security. We would also like to prevent malicious input. We have talked about it in the very first or second lecture. So there are things such as SQL injections or XSS attacks where the users can input different code and that can actually do harm to the systems. But these can be avoided with validation. Another reason for validation is user experience, because with the validation we can provide immediate feedback to the user to correct mistakes and then to make sure that the data we are receiving as input from the users are properly formed. Other reason is business rules, sometimes also called business logic, to be enforced. So we would like to enforce domain specific requirements. We will see examples about that later. And one last reason to validate is the system stability. We can also prevent crashes from unexpected data formats. Let's look into the types of validations. Here we will also have examples of what we are talking about. The first type is format validation. We are checking if the data matches the expected pattern. Let's look at the example. So an email has to have a certain pattern. So for example, we should have this symbol, and then usually there's this domain name which is formed by a name and then an extension after that. In this example it's .com. So the second email example is not valid, so it doesn't have and it doesn't look like a correct domain name, or the username is not existent. Similarly, in the phone example, we know that the phone number is composed of numbers, of course. So if you get alphabetic characters, then it's not a valid phone number. Another type of validation is the range validation. We would like to ensure that the user input fall within acceptable range or limits. Let's look at the age example. So if we would like to validate that the age is between, let's say, 18 and 65, if we get user input as 25, it's within the range, so it's valid. But if we get 150, it is out of the range, so therefore invalid. It could also be password length as another common example. So let's say the password should be longer than a certain level, so that it will be more difficult to break the password by brute force. So let's say we would like to have it between 8 to 20 characters. So if we get just 3 characters, like 1, 2, 3, it's not a valid password. Another type of validation is the required validation. So a field must have a value. So a real example that we will also go through in the hands-on part is the first name cannot be blank. So if we have a value in for the first name, in this example John, then it's valid. If we don't have any value, it could be space or blank, or it could be null, then these are not valid. Another type is business logic validation. As we mentioned before, we would like to enforce domain-specific rules. What are those rules? One example, so graduation year must be after the enrollment year of a student. So if the enrollment year is 2020, the graduation year cannot be 2019. But 2024 would be a valid graduation year. Another example is discount cannot exceed the product price. So if the price of a product is 100 units, then the discount cannot be 150, because then it's larger than the product price. Next is the cross-field validation. Another common real-life example is the passwords need to be confirmed to avoid mistakes, typos. So if there is a certain value of the password, in this example mypass123, if the confirmed password is different than that, that is not valid. So here we are validating relationship between multiple fields. Let's look at the validation in different layers. So we currently work on the front end, and that can also be called as the client side. This is relatively the weakest layer for validations, because this is the layer where we are receiving the user input. Therefore, it's not suitable for security enforcement, because there are a lot of different ways to bypass this client-side validation. You can use this API tools, you can use this developer tools, so therefore you can bypass those front-end validations in different ways. However, it is good and suitable for immediate user feedback, so we can guide the user. Next is the backend, or the server side. This is good for security enforcement, and this is also where the business logic validation happens. This is the layer. In the previous layer, client side, we were getting the user inputs. This is the layer where we are receiving the HTTP requests. So we can also perform data sanitization and data transformation here. We can check the authorization. So in a nutshell, this is where the major validation takes place. Finally, there's the data layer or database layer. You will remember from the database lecture, we have integrity constraints, SQL constraints, so that's where we can enforce these. And then we can also consider this layer as the last line of defense. Let us look into validation in Angular. There are two different types of validations. So one type is the template-driven validation. This is also called declarative. Here the validations are defined directly in the HTML template. The other type is called reactive forms validation. It's more programmatic. Therefore, the validations are defined in the component's TypeScript code. In Angular, there are built-in validators. So, for example, required, when the field must have value, and then minimum and maximum length for the character length, and minimum, maximum, this time for the numeric value, and email for the valid email format, and then regular expressions for pattern matching. There are also different states in Angular. So there's valid, invalid state. It is used, for example, in enabling, disabling buttons. We will see in the hands-on part. There can also be touched, untouched, meaning user interacted with the field or not. And then the use can be, you can show the errors only after interaction. Then there's also dirty or pristine. Um, Here we look at if the value changed from the initial, and then in such cases we can warn about unsaved changes. There are also states called pending and errors. We will see errors in the hands-on part. Let me quickly go through pending. Pending means asynchronous validation in progress. Therefore, for example, we can show a waiting or loading spinner. Errors is an object with validation errors. The use of it is we can display specific error messages. Let's look at validation best practices. Progressive enhancement. So we can show errors progressively. We just mentioned in the previous slides about, for example, dirty and touched and invalid. In this example, if the field is dirty or touched, and then if the field is at the same time invalid, then we can only show after this, only show the errors after this user interaction. Next one is we need to provide easy to understand, useful and clear error messages. So this is a common pitfall. It's lazier and easy to write very concise, short error messages. For example, invalid input. It doesn't tell us much, but a better error message would be email must contain @ and domain, and here's an example. Validate early, validate often. It's inspired by test early, test often. So we can validate on the user input, for example, and that would be the real-time feedback. We can catch all the errors during form submission, and then we can have the final validation from the server response. Now, when we have buttons, it's a good idea not to enable buttons, especially the submit type of buttons, when the input is invalid. Here you can see the student form. If it is invalid, the button will be disabled, so we are avoiding to corrupt our database or backend with any invalid user data. Now we will jump to a very different topic. So this is just an appetizer. It's a bigger topic, but we will take it in a very simple way. It's the product mindset. Let's first define what product mindset is. A product mindset represents a fundamental shift from output-focused execution to outcome-driven value creation. So rather than viewing work as discrete projects with defined endpoints, product thinking emphasizes continuous evolution, user centricity, and measurable impact on business objectives. Here is a core distinction. When we have the project mindset, it can be such as build feature X by date Y within budget Z. But when we have the product mindset, we will most likely look into that as solve problem X for user Y to achieve outcome Z. Another example, if we have output thinking, we might be talking like we shipped 15 features this quarter. But when we have the outcome thinking, it can be such as we increased user retention by 23% this quarter. So as you can see, the first one is sometimes also called as feature factory in the industry. So you're counting the number of features you have been shipping, but that doesn't guarantee the user value. That doesn't guarantee that your customers will be happier or will be using all these features. However, when you have the outcome thinking, you, for example, in this example, you look at the improvement in the user retention rather than number of features. The project and product also differs in terms of teams. I also work with product teams, and here the differences are very roughly. In project teams, you assemble the teams depending on the initiatives. But in product teams, you try to have more consistent, long-living, and persistent team ownership. So in project teams, you have requirements, you execute the requirements. In product teams, you try to define solutions. Project teams are accountable delivery, but product teams are accountable for outcomes. The first thing we said was project teams are assembled for initiatives, therefore they disband after completion, so they don't have a longer lifespan. The product teams, however, continuously try to improve the product. Next part is the product metrics. So let's go through different metrics, starting with the activity metrics, sometimes also called vanity metrics. So first let us give some examples. This could be the page views, number of downloads, feature usage. A common thing is they are easy to measure, but they are not good indicators of value. They can increase, your metrics can be improving, even when the business value declines. Another type of product metrics is outcome metrics. Examples to that could be, we already had this example about user retention. It can also be task completion, engagement depth, and other things. Common things in outcome metrics is they indicate whether the product creates user value. Also, they have direct connection to the user behavior. Another class of metrics is business metrics, and these are more strategic. So revenue, profit, market share, customer lifetime value. The common thing here is these are the ultimate measures of the product success, and these have longer feedback cycles. Finally, we have so-called North Star metrics. Actually, this is a single metric capturing the core value of the core value creation of the business. Here we have examples from real big players in the market. So for example, for Airbnb, it could be the nights booked. For Facebook, it could be the number of daily active users. And for Spotify, it could be the time listening. Let us continue with the hands-on part where we can also see some of the things we learned in action. We have started developing our code in lecture 4 and we are continuing from where we left off at the end of lecture 6. In fact, we continue from the end of exercise session after lecture 6. So you can continue with your own code, or if you like, you can also just download the code from Canvas. As you can see under lecture 6, you will find a zip file named code after e06.zip, and when you download it and extract the contents of it, you will find two folders, one with the backend code and another with the front-end code. As you know, the backend code contains especially our web API project, and the front-end code contains our Angular project. And I will open the code in Visual Studio Code or VS Code in two different instances, and I will start first by running the backend code. So let's just open the folder and then point to where we have downloaded our code and choose the backend folder. Here I would like to help you with a possible warning or a problem, especially in macOS, where the system may not find the code trustable. So the system may not trust the code. In this case, you just click on the question mark, and then the operating system will guide you how to bypass this warning. So in this case, we just go to the settings and then open the privacy and security settings as advised. And then we scroll down because it's divided in this case as privacy and security separately. So when we scroll down, we will see in security we can actually allow especially this project anyway. And then we can dismiss the error, and then we try to run the project. And this time we see another option which is open anyway, which may require elevated access. Therefore you might need to enter your password. And this may all be operating system specific. But now you will see that the backend runs, and in my case it automatically triggers Swagger. It should also be like that if you correctly installed Swagger or you use the .NET SDK version 8 instead of the latest one. Alright, so let's get a new window of Visual Studio Code where this time we will run the front end. And just like before, we just need to open the front end folder. And of course, this code doesn't have all the node packages, so we need to open a new terminal window, and then we need to run npm install such that all the necessary packages will be installed to your local folder. After that, we run ngserve so that we can launch our website from our local web server. Now we see the address. We have to click on the address. There we go. Now we can see the simple page with two links, student list and teacher list. And when we click on student list, we should be able to see the records we have created. As you can see, I had played with it, so I have a little bit more of records. And then we also can see the delete button, which we implemented last time. When we click on teacher list, we do not have any buttons and our tables are not as fancy as in the student list, but we should still be able to see the records that we have in the database. The first thing we are going to do is we will start a new terminal window, and then we will create a new component. And if you remember, the command we use to create a new component is called ng space generate space component space the name of the component. In this case, we will create edit student component. As the name suggests, we will be able to edit the student records when we are done with this component. When the command is successful, you should see under src source and app folder that the edit-student folder is created, and inside there are 4 files that make the component. Before making any change in edit student component, we go back to our student card component and then we work there. So we start with the what we call as the template, which is the HTML part of the component. First, I want to remind you what we have here. So this is HTML code, and what we see is an HTML table. You can understand from the outermost tags, we start with table tag and then we end with slash table tag. Inside we have these table rows. That's how we create an HTML table. We start with tr table row tags. Again, we start it, we close it, and you can see there are several rows here. Inside the table rows, we have the table columns that you will realize by the td tags. And then whatever we write between td and slash td tags will be displayed inside the cell of the table. For example, in the top row between td tags, I see ID, which will be displayed in the first column of the top row, and then in the second column we see double curly braces. That, I have to remind you, is called Angular's interpolation syntax. It basically displays the value of the variable, which in this case is student.id, from the component's TypeScript code. So the double curly braces tell Angular to evaluate the expression and render its value. And then at the bottom, you see that there's a different row. In this row, we have this delete button. Now, what we are doing is we are going to change this row. First of all, we will make sure that the row also has TD, which stands for the column. But we will have a special TD where we will write colspan equals to 2, meaning that actually we will have one single column spanning two different columns. When we do that, we will make sure that the buttons are not in separate columns, but actually they are together spanning the table. I also want to remind you that we use this div tags, which is very basic. It's just a container, and in this case we use it as a single container for our buttons. And then we will add a copy of the delete student button, and we will rename it as edit student. We will make a change. So in this case, we design the edit student method to take an input parameter, which will be the unique identifier of student. In this case, student.id. For practical reasons, we also need to make the edit student come before the delete student button. Let me also finally explain the button code. So the action between the parentheses means that when the button is clicked, and then after the equal sign, we see which method is called. So it is, for example, delete student method or the edit student method. In Angular, this syntax is called event binding syntax. As you can see, when we are done with the template, it is actually highlighted in red because we didn't define the edit student method yet, which we will do in this next step. To be able to do that, we go to the TypeScript part of the component. Again, let me first explain you the existing code here. In the top part, we see the import statements. So we first import the student model that defines the structure of the student data. Then we import the student service, which actually handles the API calls for student operations. So you can see the service as what connects front-end to the web API. And then we import component and input. Component is actually the decorator to define this as an Angular component, and input is the decorator to receive data from parent component. And then below that we see the component structure, starting with the component decorator we just mentioned. The first part, the selector, is the HTML tag to use this component. So for example, if we want to use this component, we use this app-student-card inside brackets. And then next we have the imports. Right now it's empty. It will be filled about the dependencies that this component needs. Next one is the path to the HTML template file, which is followed by the path to the CSS Cascade Stylesheet file. Now inside the student card class, we first see a single line for the constructor. As you can see, constructor is getting an input parameter. This is actually a design pattern that is called dependency injection. It is when a class receives its dependencies from external sources rather than creating them itself. So in this case, we are using dependency injection with the student service, and you also see private before the student service, which makes it accessible through the class. I already told you that the student service is used for the API calls. After the constructor, we see the input decorator. As I mentioned when I was talking about the imports, here the use of it is we receive student data from student component. Note that there is an exclamation mark right after the student, which actually tells TypeScript that this student will be set before the use. Right now it's not set, but it will be set. Currently we already only have the delete student method, which calls the service to delete the student. It uses this .student.id from the input property, and then it uses .subscribe method, which executes the observable, which is required for HTTP requests. And then this function actually does not return anything. Overall purpose of this component, as you know, is to display a single student's information as a card with the currently delete functionality. Now we are going to add the edit functionality to it. We will start by making a new import. We will import the router from Angular/router. And this is the navigation service between the routes and pages, one can say. And then we will go to the constructor, and we will add this router to be used for the navigation. Next, we will add the edit student method. And this method, as I said when we were working on the template, it's taking a parameter, the ID of the student, and it navigates to the edit page for the student, which creates a routing such as /edit-student and /the ID of the student. Let's also add the ID to the input parameter. Now, as you can see, when we save this function, the problem or the red highlighting in the template is disappearing, because now we have defined the edit student method. Next thing we are going to do is we will add this new route to the app.routes.typescript file. Let me again start by explaining what we already have here. So the import statements, I already explained it before. It's very similar to the other TypeScript files we work with. So let me explain the route definitions. We first see the route to the student list. So it basically displays the student list component. And then the address is basically our address / students. And then the next route we see is the teachers. Let me start with the address this time. So the address will be the local address and of the app and / teachers. The component that it will display will be the teacher list component. So the purpose will be, of course, showing a list of teachers. And now we are going to add a new route, the route that we just created. It will be a different route compared to students and teachers, because after the address of our application, we will have the edit-student, and then we will have another / and then we will have the student ID. So therefore it will be dynamic values. As you can see with the column and ID, that value can be different depending on the student's ID. Of course, the component that will be displayed will be the edit student component. We also need to import this component, and now we don't have any syntax errors anymore. As you can see, a route is basically mapping a URL path to the components. And now it's time to test it. If we refresh our page, we now see the edit button next to the delete button. And that is under each student record. When we click the edit button, we just see the default text which says the component works. And as you can see, it's not two separate columns. We use the call span in the HTML table. Now, the next thing we need to do is we need to go to the app.config.ts file. Let me again first explain what we already have in this file. So app.config is the central configuration for our Angular application. It sets up essential services and features that our entire app will need. Application config, as you can see, the class, actually the object, it's a configuration object that tells Angular how to start up our application. It's used in main.ts when the app launches. And then you can see inside the application config, there's an array called providers. What it does is it registers application-wide services and features. So in this array, the first row you see, the first line you see is this global error listeners. They set up global error handling for uncoded errors, and they are catching errors that occur anywhere in the application. They also log errors to the console and help with the debugging. The second line you see is about zone change detection, because Angular uses something called zone.js to detect when the data changes. This automatically updates the UI when events occur. And you already seen one type of event, which was the click event when we defined our buttons. But there can also be other events such as HTTP responses, timers, etc. And here you also see a parameter called event coalescing. This is basically a performance optimization when we set it as true. It works such as multiple events happening quickly. Those are grouped together. That's basically the optimization. So instead of checking for changes 10 times, Angular will check once after many events complete. And the third line is the router configuration. It registers the routing system. It uses the routes array that we defined, you will remember, in app.routes.ts. So it enables navigation between different components and views. The next part is the HTTP client. It registers Angular's HTTP client service, which is actually enabling us to make the get, post, put, delete requests. Those are the HTTP requests you remember from the web API. It is required for our student service to work. Now we start with extending one of the existing imports with component input binding. I will explain in a second, where we also make the change inside the provider's array. So we go to the third element of the provider's array, which is provide router. And then inside the parentheses next to routes, we add this with component input binding. So what happens here is, this is actually a really nice feature that simplifies the route parameters. It automatically binds route parameters to the component properties. Now we also need to extend this new component we created. Therefore, we need to navigate to edit-student.ts. I already explained and reminded you the import statements and the parts of the component, so we don't have to repeat it here. And inside the class, as you can see, it is already empty. So we can start making changes to the edit-students. The first thing we are going to do is to extend the import also with the input decorator, just like we did before. And now we will do something new. We will extend it with something called onInit. It is a lifecycle hook interface for the initialization logic, so that's the importance. Then we also need to import the student service for the API calls and the student model for the data structure. After that, now we will start writing the class, and we will start with using the input decorator we just imported, and that is actually inputting the ID number, and this, remember, is the magic from the with component input binding. It automatically receives the ID from the route. Remember, the route was edit-student/ID, and ID was dynamic. Also remember, the exclamation mark tells the TypeScript that this will also be assigned before use, so that we are avoiding any TypeScript error for unassigned or uninitialized variable. We say that it will be assigned. Then we have the student data, and similarly that also has the exclamation mark. The student is storing the complete student object that is fetched from the API, and the exclamation mark again tells that it will be assigned before use, so no need to give unassigned errors. Now, as you can see on the editor, I I didn't write anything about the constructor yet, but it already suggests me a constructor, which is actually a correct constructor, where, as I mentioned before, we use the dependency injection, so we have the student service that is passed to the constructor. We can also call it that Angular injects the student service so that this component can make the API calls. Now I accept the suggestion of the Visual Studio Code IDE, and I want to continue with the next part of the class. We will use this ng on init, and when we were importing it, I mentioned that it is called a lifecycle hook. What does it mean? It runs once after the component is initialized. So on the initialization, it just runs the code here. So if we can look at what happens inside this ng on init, we first have a call to the student service method with this student service dot get student, and then it returns an observable. So you can think observable as a future value. And then we have the subscribe part of the code. We just subscribe to get the data. Subscribe actually executes the HTTP request that we are making. When the data arrives, the student object actually receives the data. So you see the assignment, this.student equals to student. This is the assignment. And maybe we can explain better with a data flow example. When the user clicks on the edit button, let's say if it's the student with the ID 5, then the router navigates to the address edit-student/5, and then the edit student component is created, and then the input binding happens. Afterwards, ng on init executes, so the code inside it executes, and finally the template can now display the data. The last thing we need to do before testing the edit student component is we need to change the template, the HTML part of the component. As you remember in our previous test, there's the default data there. Now we delete it and we start writing some HTML code. I explained that div is basically a container, so we will use div blocks, div tags here, and then for each property of the student data structure, we will use a different div tag. So we start with the div for the ID, and we first write the text, and then, as you remember, we will do the interpolation syntax. You can also see that we use span. Span is basically wrapping the interpolated value. Span is used for example, styling purposes. So we can have a CSS code for spans, for example. Then we do the same thing for other parts of the student structure. So for example, first name, last name, email, phone, date of birth, and the study program. And it will all be in the same way as we did for the ID. To save time, I'm just going fast forward in this part of the video. As you can see, I modify each div one by one, and finally I can test when I click the student list, and then when I click the edit. Now instead of edit component works, I see actually a record. So this is just one of the records. It just shows that we can fetch the record here. So note that the date of birth and the study program are not populated. We will fix them later on. We just can also try in a different record, so we can just fetch the record when we click on the edit button. Now we move on, and this time we will add a new method to our web service. So therefore we go to the services folder and we find the TypeScript file for the student service. As you can see here, we have the get student, create student, and delete student. Now we will also add the update student. And as you can see, the autocomplete or the suggestions in Visual Studio Code is really nice, but we still need to be careful. So this update student method updates an existing student's information by making an HTTP put request to our backend API. As you can see, we already used get and post and delete methods. Get was for retrieving data, post was creating new data, and delete was for removing data. Now we also used put, which is for updating the existing data. And another reminder, the observable return type is representing a future value or future values that will arrive asynchronously. So it's like a promise of data which has not arrived yet. And then we also use the keyword any, which means we don't really care about the specific type of the response. So the response could be an updated object or a success message or a status code. After this, we go to the TypeScript file of the edit student component, and we will make a small addition. We will first import the forms module from Angular Forms, and then we will also add it to the imports array of the component. I will explain what we are doing in the next step, where we will edit the template, but let us first add the import here too, and then save the file, and now we go to the edit-student.html, which is our template. Alright, so you remember we just did this together with you. Now we will improve this with what we call as two-way binding. So in order to understand two-way binding, let's also look at the one-way binding. One-way binding is actually interpolation. So one-way binding is what we currently do, for example, in the ID field. So it's not editable because the IDs shouldn't change, and data flows one way, one direction, from component to the template only. Now, what we are doing with two-way binding is we are creating editable fields. So we use this ng model, which is two-way data binding in Angular. It does two things. So one thing is it takes the data from the component so that on the web page it shows the data. For example, if the first name is John, it will show John. The other thing is when the user types something on the web page, it actually updates the, for example, first name of the component. So if we replace John with Jane, then it will also update it. After changing all the div blocks except the ID, we also add a button at the bottom And you remember the syntax, so click inside the parentheses, it shows that we are listening for the click events. And then, as you can see, we are calling the update student method when the component is clicked. Now we are done in the template, but as you can see, the editor is complaining that it doesn't really know the update students method. To be able to fix that, we go to the TypeScript file of the component. First, we make something we did before in this lesson. We will just import the router from Angular, and then we will go to our constructor, which actually injects the student service. We will also add the router there, and right after that we will start fixing the missing method by adding the update student method after the ng on init. So the update student method saves the edited student data to the backend and then navigates to another page. As you can see, there is this .student service. This is the injected service instance, and then there is update student. That's actually calling the service method we just discussed earlier. After making sure that the update student method is correct, and then we are routing to the students page, then we can actually save all the unsaved files that we modified and then go try the functionality on our browser. So let's just do that. Now I'm clicking the student list and then clicking the edit, and there you can see the ID field is one way, it's not editable, and the other fields are actually editable. So now I'm changing the value of phone from string to numbers from 1 to 8, and then click the update button. And now we go back to the student list, and there you go, it's the phone number is updated. We can try also updating the email, which is also currently having a text value of string. Now we just replace it with something else. So let's say add Enigma, and then we update. There you go, it is also changed. Now I want to just show you that what we do here, it did change the data in our database. In order to do that, we will go back to pgadmin, which we started using, I think, in lecture 3, where we worked on the database. It actually takes a little bit long for pgadmin 4 to launch, so I fast forward that part. And now we can see that in the database, in the student table, I have 3 records, and I can see the email and phone data that I updated. So it means that our front end talks to our backend, and our backend actually talks to the database and changes the data in the database. So as you can see, the date of birth and study program does not really work. So we have that data in the database, but we don't see it on our web application. So next thing I'm going to do is, so we have a bug. I want to do a bug fix you can also call that we have a defect and we want to fix it. Now, in student list component, we actually have in line 18 a console log where we are actually logging the API response. So we should be able to see the content of what we fetched using that. We can see the contents of it in Visual Studio Code, but we can also see it on the developer console of the browser, which may be more interesting. So after you enable the developer console, depending on the settings of your browser, you should then be able to see the API response. So here, if we just unfold the API response, we can see that actually we are getting the study program ID and the date of birth for all the 3 records in the database. So now we verified that we can fetch the data through API, but we are not able to display it, so the problem should be in our front-end code. And in this case, it's easy because, as you can see, the study program is here called study program ID, and date of birth is in our code, it's DOB, here it's called date of birth. So we simply have a mismatch. We have different names for these fields in our front end. The fix will be easy, so we will as such rename the front end variables to match the API response. There are 3 files we need to change. One of them is inside the model. So as you can see in the student model, it's called study program. Now we change it to study program ID, and then we go to the student card template, and here it's already highlighted because now it's study program ID. We just go fix it by adding the ID, appending it, and then similar in edit student HTML. So now we made changes in 3 different files, and voila, you can already see that study program works. We see the value of 1. That was actually what we fetched through the API. I just need to also make a similar change for the DOB. I simply have to rename it as date of birth, and then we need to change the 2 places that we use date of birth, so DOB to date of birth, and then when I save all the files, then I can also see the date of birth, so it's like a timestamp in all the 3 records I have. I can close the developer console. So now we fixed our bug. As you can see, we actually have one more thing to fix. So the study program data that we are storing in the table and then passing to our backend and frontend is just the ID of the study program. So it's not user friendly. So we shouldn't be seeing 1 or 2 or 3. We should see the name of the study program. We will not fix it today. We will fix it at another point of time. So we move on to make to implement validations inside the edit student component where we have this editable fields. Let me explain what happens here. As you remember, in the first div container, we display the student ID. This is a simple string interpolation. We just display the ID. This is read-only. In other words, it's not editable. But then in the second div container, with the first name, we do two-way data binding, which we know from the use of ng model. And two-way means that we bind the input value to the student.firstName property, and then if there's any change in the input, update the model, and vice versa. This requires forms module, which we imported in the component. That's what we already did in this lesson, so let's continue with adding the validation. We start by typing required. Required is a built-in HTML Angular validator. It in fact makes this field mandatory, and it sets the field as invalid if the user tries to leave it as empty. Then we write a hash sign and then first name, and then we assign ng model to the value of it. Here what we do is we create a reference variable in this template, so it's a local reference to the ng model directive. What it does is it allows access to the validation state so that we can see if it is valid or invalid, for example. And then we have an if decorator. It is actually, as you remember, we used before, it's control flow in Angular, and it conditionally displays the error message in our case. So, for example, here it shows when the field is invalid, in this case, if it is empty. So now we are also typing what it will show. So we will just display first name must be provided if it is invalid. In this case, if user tries to leave it empty. Now for the second div block, for the next div container, the last name, I will basically do the same thing as the first name. So therefore I'm simply copy pasting. I just need to change the local reference variable from first name to last name, and then I will use it in the conditional. So in this case, if the last name is invalid, I will display this warning, last name must be provided. So we use the similar pattern. The next div container is email. So we will not have any validation there, also not in phone or date of birth or so on. So it means that actually those are optional fields. So they are not required fields. The user can leave them blank. However, for the study program, I will do something special. As you remember, currently the study program is just a number. It's an ID. So therefore, I still write required so that the field must have a value. But in the I just add a pattern, and the pattern is, for example, \d plus means that it must only contain digits, and as we see plus, it means one or more digits. Then we also add the minimum length is 1 and the maximum length is 2, so it can maximum be 2 characters. So in other words, it will accept values between 1 and 99. Then we also add error specific message. So if there are study program errors, we check for the required error, and the errors is an object containing all the validation errors. We use this question mark, which is the syntax for optional chaining, so it prevents errors if the errors is null. And then the bracket notation, where we have required inside, it accesses the specific error key. As you can see, the autocomplete is a little bit misleading here. So as I tried to explain, we are first looking at the required error. So the warning text shouldn't be, it must be a number between 1 and 99. It must be actually study program is a required field. So let us just change that. So study program is required. Yes. And then we do another check. So we just copy paste the if block. But this time it's not a required check. So we don't check if for the required field. We check for the pattern. And we already defined the pattern above. So now we are checking if there's a mismatch to the pattern. And if there is a mismatch, we display only digits. So we are telling the user that the user should only input digits, not other characters. After that, what we are trying to do is, instead of always displaying the button, we have a conditional button display. So if any of these three fields are invalid, so what are these fields that we added validation? They are first name, last name, and then the study program ID. If any of those are invalid, then we want to show a message and not really display the button. So now we use the pipes, double pipes, which stand for OR. So if this or that is invalid, then we are displaying error in data. And if it's not, so if none of the validations fail, we have the else decorator, then we are displaying our update student button. When we are done with this code change, actually this concludes the hands-on part of this lecture. So let us just go to our browser and check the functionality. So let's just click the edit button. We have this two-way binding and editable fields. Let's try to leave first name blank, and then we get this warning displayed. First name must be provided, so it works. So let's add a first name, and in this case we added a different first name. Let's also check the validation on last name. So let's try to delete it. And yes, when we delete, we immediately see the warning, last name must also be provided. Remember, we not only added validation to first name and last name, but we also added validation to the study program. So let's try to leave it blank, and then we get the study program is required. And we try to write more than 2 digits, it's not possible. And if we try to enter something that's not a digit, not a number, then we get the warning only digits.